Hello, class. I hope your day is good. So today we'll be looking at filtration and crystallization. You'll recall we treated separation technique the last time, where we talked about sieving, use of magnets, and decantation and other forms of separation techniques. Today we'll be looking at two major types, filtration and crystallization. Okay, so the learning objective is that you should be able to describe the entire process of filtration and the apparatus needed for filtration, and also explain the entire process of crystallization and also the apparatus that is used for this process. Thirdly, you should be able to apply this knowledge to separating mixtures, okay, and to know when to use them, how to use them to achieve great results. Okay, so before we go on, the first thing we're going to do is to define the terminologies that are associated with these techniques. Okay, the first terminology we'll be looking at is solute. What is a solute? A solute is a substance, in most cases solid. It can also be liquid anyway. It's a substance that dissolves in a solvent, okay? And of course, the solvent, on the other hand, is a liquid the solute dissolves in, okay? So that is what a solvent is. Okay, take for example, you have water and the common salt you use at home to season your food. When you apply the salt in water, the salt will dissolve. Okay, you stir, you get a solution. Okay, so the water is a solvent because it's the bulk where the solute is dissolved into. Okay, and the solute in this question is your salt. Okay, so that's a real life application and use of these terminologies. Okay, so another one we'll be looking at is what is a saturated solution? Okay, what is a saturated solution? When we say a solution is saturated, it simply means the solution can no longer dissolve any solute further. Okay, so this you can apply by taking small amounts of water and apply plenty amount of salt in it. Keep on stirring. When the salt dissolves, you add a little. Keep on adding until you get to a point where you start seeing crystals of the salt in water remaining undissolved. At that point, that solution is said to be saturated. Okay, it means it can no longer take on more salt, can't dissolve more salt anymore. Okay, so another terminology we'll be looking at is filtrate. Okay, filtrate is the liquid, is a liquid that comes through the filter paper. Okay, so that is what a filtrate is. And then the opposite of that is your residue. The residue is what is left on the filter paper. Residue is a solid that is left on the filter paper. Okay, so take note of these major terminologies in the course of the class. We'll be making use of these terminology. So it is good we know what they mean and when to use them. So for the sake of time, I will explain filtration. You can check on the part 2 of this video to get to understand the part of crystallization. Okay. For filtration, filtration is basically used for a mixture containing undissolved solid in water. In a solvent, you have undissolved solid. It means you can filter. Take, for example, sand in water. Sand cannot dissolve in water. Okay, so that is having an insoluble solid in the liquid. Okay, so take note of this word, a mixture of insoluble solid and liquid. Okay, so this is, once you see a mixture that have an insoluble solid in a liquid mixture, you should know the separation technique that you can use for that separation is filtration. Okay. Other technique that can be used for this is your centrifugation and decantation. But for today, we'll focus on the use of filtration, okay, as a technique for separating insoluble solid in solution. Another example of a mixture containing insoluble solid in water or in a solvent is starch powder, sprinkled in water. When you have starch powder, pulling grains in water, there's no way they can't dissolve in water. So it will make your water cloudy and unclear. So if you want to get your clear water back and get your starch on the other end, you carry out filtration. Okay, when you carry out this procedure, the starch will be left on the filter paper as the residue. And then the water will pass through the filter paper and you get your colorless water back. Okay, let's look at this diagram and that will facilitate our understanding of what we have been saying. So the filter paper is folded. I taught you how to fold the filter paper the last time. Filter paper is round. You fold it into 4. First as a semicircle, and then thirdly as a quadrant. And then you make a cone out of it. Place it in the funnel before pouring the mixture. Okay? Pouring this mixture, you can see these solid particles, some of them remained on the filter paper. So these are known as your residue. Okay? So the example I gave about starch or pulling grain in water, you will see your starch or pulling grain or the sand on the filter paper, while your water will pass through, solvent will pass through, clear. So this liquid that passes through is known as your filtrate. Okay, you can see these terminologies coming into play now. Okay, so what is left on your filter paper is the residue, and what passes through the filter paper is the filtrate. So with this technique, you can separate, remember, insoluble solids such as sand, powder like talc powder, pollen grains, starch powder, mixed in water. You can actually separate them. Soya bean flour, any kind of flour mixed in water, you can actually separate them by using filtration, because these solids don't dissolve in water. Okay, they only make the water look cloudy and unclear. Okay, so if you want to get a clear water back, you carry out this technique. So we'll stop here today. Or we'll meet next time. I'm going to talk about crystallization. Okay. I know you'll be wondering, oh, now that we've talked about a mixture containing insoluble solid and liquid, what about mixtures that contain soluble solid and liquid? Make sure you subscribe and follow the channel for the next video on how to separate that. Okay, till we meet again. Bye.